So today we're going to take a look at applications for quadratic functions. Okay. So few of the things that we're going to take a look at is some practical applications of what quadratic functions are and how the vertex x-intercepts and y-intercepts play a role in these situations. Also, when we're trying to find the value of x when y is given, or finding the value of y when x is given. So, and where do we use which function? Okay. So before I go through going through an actual example and setting it up, let's just take a look at a scenario and seeing how does the situation where these applications fit into the parabola shape or the quadratic function. So what we call them is projectiles, but they're basically an object that it's thrown into the air. So we'll take a look at, it could be any object thrown into the air, but I'm going to just use an example of a ball being thrown. And there's two scenarios that usually come into being. One is, let's say the ball is launched from the ground or kicked from the ground. So remember, it can be a ball, it could be any other object, and it could be launched or being initial sent through is from the ground. So when if something is kicked like a ball from the ground, it will usually go up and then go up to a height and then come and hit the ground. Okay. So if you think about an upside down parabola, that's basically the shape of it. It's an upside down parabola where we will look at the x and y axes. So the ground acts like the x-axis here, and the height that we throw it in the up in the air is like your y-axis. So this becomes the height, and the x-axis can be either the time or the distance going horizontally. So let's first take a look of just thinking of it as a time. So initially, when the ball is just sitting on the ground, your height is 0 and your time is 0. So remember, we always start with the x and y point. So it is 0 seconds because nothing has really started, and the height is also, let's say, 0 meters. So we're sitting on the ground at the start, no height, no time hasn't started. The moment you hit the ball, the time starts ticking, and you can see the height is getting higher and higher. You can visualize the ball going up until a certain point when it's going to reach its maximum height, and then it's going to start coming down. So this is the point that I said it reaches the maximum height. So that's like your vertex, where x would be the time and k would here be the height. Because x is always the time, y will always be the height in this scenario. So what does this maximum point or the vertex represent? It will represent that it will take h seconds to reach maximum height of k, let's say if it's in meters. Okay, so you have your h is the time that it takes the maximum height. So this h and k are very special points because they represent the maximum point here. And if I want to know how long it took, I will look at h, and if I want to look at how high it gets to the maximum point, I will look at the k. So I call this is the first point, this is the launch point, this is the second point, the maximum, and then the last point is right here when the ball hits the ground. So this also has an x and y point, but what does that represent? So this is the point when basically our height will come back to 0 because it's hitting the ground. Okay, so we're basically interested here is what time, how long did it took for it to come back and hit the ground. So this point is your y-intercept right here. Sorry, x-intercept right here. So x-intercept is always a point where we have an x point where the y is always 0. So this is our third major point. So how long did it take for the ball to come and hit the ground. So if it started at 0 seconds, how long did it come back to hit the ground again? So the first point is your launch point. That is basically your y-intercept sitting right here. Second point is your vertex. And then this is your third point, which is your x-intercept. So same scenario can be also given in when we have a ball is launched from a certain height. So not every time the ball is going to be hit from the ground. It can be kicked off a building. In this case, maybe a person is throwing off with their hands rather than kicking them from the ground. Or in this case, I just made a table. And you'll notice over here, we still have those 3 points. The second point is still your vertex, the maximum height and the time. The third point is still your x-intercept here. So it tells us basically when does the ball come and hit the ground. But that first point here, it is still your y-intercept here. But in this case, the time is still 0, but there's going to be a certain height that you're going to launch the ball from. So this point, y point, becomes your launch height. Okay, so when we threw it from the ground, these both points were 0, 0 because the ball was sitting on the ground. The height was 0, but at this point the height is at certain, it's away from the ground, so you will find a value of y here. So these 3 points, y-intercept, vertex, x-intercept, they all represent something. Launch, maximum, and then the last one is when it hits the ground. Okay, and we will also go through an example where we'll have an equation, and then we will find these points using our calculator. So, but keep in mind, those are the 3 points in every scenario in these projectile questions.